What are you showing us?
It's about rig inspections, and we're going to go over the lower part of this entire rig, and it's basically just like it sounds. You just look at everything, but I'm going to highlight some of the things that are easy to overlook, or failure modes that you often find. So starting here, the cotter pins, sometimes they're not bent, sometimes they're missing. Sometimes they are of a low quality stainless and they're corroded badly. These toggles, this part here rarely gives any trouble. I don't think I've ever seen one fail. This part here occasionally will develop cracks, and they usually start here, radiate out in the corners, and you'll see that by you'll see that it'll be highlighted by corrosion. In this case, there's no problem with that. Moving on up to the turnbuckles, they need to have pins, top and bottom, to keep them from turning. It does. This is a good quality open bronze turnbuckle. I've seen 2 fail, I believe, in 12 years, and both of them, one was a very low quality turnbuckle, low quality silicon bronze, and the other one was hit and bent, physically hit by something, and it just fell apart one night. The boat was on the hard, just sitting there. Okay, so the next thing is the swage. Oftentimes there's a swage at the lower end. Sometimes we'll have Staloks or Hymods or Norsemen. All of these things are prone to crevice corrosion, and this is a swage. It's called a 2-pass passive die, which means that they went through the first time they put there's 2 dies basically, and they rolled it up like that, and then they turned this thing 90 degrees in the machine, and as the first pass it would have left behind a little ridge, and they went back and rolled that ridge flat. It's got a lot of initial strength, but they tend to fail right here, right where the ridge was, the edges of that ridge. So this is a place you want to look for little spots of corrosion, and if you see them, which we may, I believe there's some more other places on this boat, we will scratch that off and try and determine if it's a crack or if it's just surface rust. This one's slightly bent, and you can see it's not quite straight.
Yeah.
It's not bad. Sometimes you'll see them quite bent, and it's an indication of a machine that wasn't heavy duty enough to handle the swage that they were making, and indicative of low quality work. And it also puts extra stress on the wire, because if the swage is bent and the wire comes out like this, then the wire, the strands on, for example, this one's bent that direction. So these strands actually have more pressure on them than these strands. And when you unequally load the wire like that, obviously it's going to cause these to be have too much load on them. Another failure mode that we had on that boat from this morning is these wires will break down inside there, and it's hard to see. Sometimes you'll see there's a little tiny gap where the wire has broken and come out, but it's because of the end of where the swage presses on the wire is just right about here. So that, where it goes from being work hardened to not work hardened, is a weak point. And they more often do that at the upper end than at the lower. But you can sometimes see that by noticing a slight discrepancy in the lay of the wire, like it seems to be a little bit off. That can point out to you a broken strand in a swage terminal. So moving on to uppers, this is ancient. They haven't made these in, I don't know, 20 years at least. And so anytime you see this type of turnbuckle, you know you're going to have to replace the turnbuckle. We usually do replace turnbuckles when we replace it, but they have a tendency to break right in here, similar to these toggles. It breaks, you know, have a tendency to crack right there. Then also, of course, you have the places on the swage, the same thing where they have a tendency to crack, where that ridge was smashed down. These lower shrouds have been replaced more recently than this upper because this is a much older style of terminal, and I'm sure the entire boat had this style of turnbuckle. But then when they replaced them, somewhat more recently, they replaced the turnbuckles and used open bronze, which is a more modern method. Anytime you find a rigging that's got different time periods, one thing replaced and another one not, you have to be a little leery of that because it's not a good sign.
Oh, yes.
This here is a different kind of swage. This is the type of swaging I prefer to use. It's called a rotary swage, and you notice there's no ridge on this. It's completely round. And these swages, with very few exceptions, will last as long as the wire. And so oftentimes if you see a swage like this, you want to make sure, or a Stalock or a Norseman or a High Mod, a mechanical terminal as well, last longer than the wire. And so these ones you'll want to make sure that you check the wire a little bit more carefully. And forestay, it's a Profurl, I believe it's a 42 millimeter foil. It's kind of unfortunate they have the drum so low, and if we were to replace the rigging on this, I would definitely move the drum, get a longer plate here. If this is just it's called a link plate, but it's only this long, but you can buy them much longer, and I would move this drum up to here so it won't get hit by the anchor chain as it comes up and down. I think it's mud on it and salt water, but it turns freely, no problem with the bearings. The thread is still in decent shape in the sacrificial. Not really part of the rigging, but I checked that anyway. It's got its pin here, and that's about all you're going to be able to see. Everything else in this, there's a bolt there that goes through it's an eye fitting. It's probably an eye with threads in it, and there's a stud on the end of the wire that's threaded into the eye, which is a common thing to do at the factory, which makes you wonder just how old this is, because the boat's 40 years old. I suspect some of the rigging may be as well, although it may be a newer installation as well. They may have put that on after the boat was built. But there's no telling. There's no way to really inspect anything on the forestay because, well, there's a furler on it. All right, let's go look at the back stays, which right there is a broken wire on this. And over there, you can see a couple break, and there's another broken one there, another broken one there. It's unusual to have wire do that, and I've seen that more often when the rig is freaking ancient. I suspect that in this case, since they have these Stalock fittings here, I suspect they may have, well, I don't know, but the upper ends are forked, which is an old-fashioned thing to use. I don't know. It may all be original. It may have been cobbled together. So this may be a wire that came from somewhere else of a lower quality than the original rigging. But nevertheless, when they start snapping like that, it's
No bueno.
It's finished.
it's done. One
Garbage.
thing, the terminals up there, the fork terminals, they're called aircraft forks, and what they have an undersized pin for the wire size. Basically, all the aircraft forks are one size below what's called a marine eye, and so if we change out the rigging again, I'm going to change that. And instead of using an aircraft fork, I always use a marine eye, and I'll replace that single delta plate with 2 delta plates, and have a stronger connection there at that junction. And I'm not going to reuse the Stay-Lock insulators for 2 reasons. One is that they start to break down in the sunlight after about 25 or 30 years. So while they may be fine now, they're not going to make it for another 15 or 20 years, which I assume would be some of the life of the rigging that we replace. So, and instead of using Stay-Lock insulators for an SSB antenna, I prefer to use a piece of wire, or there are a number of different antenna styles that don't use the rig, and I say compromise the rigging, because these can melt in a lightning strike and cause the backstay to fail, which seems an inappropriate use of rigging, to have something making it into an antenna but compromising the strength of the standing rigging.
Not to mention we don't have the SSB anymore, so.
Not to mention there's nothing attached to that. Yes.
It's not even working anymore.
No. You can see the backstay is completely shut like this. That can be an indication that the mast is sinking into the boat. You know something about this, I believe. Whether it's sinking into, if it's keel step, whether there's sometimes the base where the mast sits on the keel is corroded, or sometimes it's wood underneath there and it's rotten, or if it's deck step, sometimes there'll be a problem with the compression post, or if there's a beam underneath there that can sink, or the deck itself can rot out underneath the mast base. All these things can lead to a suspicious number of turnbuckles being completely closed. Now this is the only pair, these backstays, they're both completely shut. But the shrouds don't appear to change. They're not like if everything was totally shut, something moved, because no one makes a rig this badly, so that everything is completely shut. But the backstays, oftentimes when you have a forestay like this that's a set length, it's not adjustable, then the backstays have to be pretty long just to be able to connect them. And then to actually put tension on them, you end up using the entire turnbuckle. So it's not terribly unusual. And when you do find that, you find it more often in the backstay than any other wire. Because the shrouds, they only close, maybe a half an inch and done. With the backstay, if you're not tensioning the forestay, then it's like the entire wire. So say 100 feet of wire, you're having to pull taut with just one turnbuckle, as opposed to the lower shrouds where you're only tensioning 20 feet of wire, and you don't really need to do much to make it tight. Anyway, everything else looks fine here, other than the fact that the wire is pretty badly compromised. Moving on, here's a little bit of corrosion. The wire looks normal, but right there, so we'll use the caliper, clean that off, and I don't see any problem. If it's starting to crack, it's really, really tiny. More down here. And this salt water sitting here in the top of the swage, and then it spills down and stains the swage there. So as you can see on this mast, the mizzen, the upper shroud with the 3/8 open bronze turnbuckle has been replaced more recently than the lower shroud with this old-fashioned turnbuckle. Moving on, same thing, totally closed. And this was the one that's got, I don't know, at least 2 strands, probably more, but they're broken in a whole bunch of different places. And it appears to have some corrosion coming out down here. No obvious sign of a crack. Oftentimes you can feel the crack with your calipers as you run across the surface. I don't feel anything, and once you scrape off the corrosion, yeah, it looks good. And that's
How
pretty
about
much
the
it.
this is other type of metal or what?
This is bronze,
Yeah.
and this is stainless. Whereas in the modern turnbuckles, this is bronze, and that's the stainless. But the reason to do that is so that you don't gall the threads, because if you put a stainless thread inside a stainless turnbuckle, that stainless on stainless, if there's enough friction, like if it's old and salty, and it can gall the threads, which means that when you move it, so much heat is produced by the friction that the threads will become brittle and can snap, can break, cause failure. And for that reason, I don't use stainless steel turnbuckles, and I usually replace them when I do rigging, because whereas bronze is a lifetime is pretty much totally passive in a saltwater environment, and it can easily last for 60, 80 years. Whereas stainless is not. Stainless can develop crevice corrosion inside the stainless and cause a galvanic reaction between the chrome and the steel, which is what we keep looking for when you see the little bits of corrosion. We're looking for water, salt water, that had gotten inside in an anoxic environment and is causing that galvanic cell to be created inside the stainless. That's its favorite failure mode, stainless steel. So some things like these clevis pins don't have any place where water can get in, the air can't. It's just a round pin. So it's not prone to crevice corrosion, and they almost never fail. On the other hand, a swage, where a little bit of water can get down inside this fitting, they are prone to crevice corrosion, because a little bit of water can get in there but no air, and that's when stainless causes lots and lots of headaches. And it's also dependent upon the quality of the stainless steel as well. Specs on both sides are the same, and if they were both loose, we'd start looking for a problem at the mast base. But since just the lowers are loose, we probably just weren't tensioned very well. And no one ever noticed, because the mizzen doesn't really. It's not exerting that much force on the lowers, and so if the mast is a little bit bent when you're sailing, you wouldn't notice the difference. Now, So anyway, I'm gonna go up top. Same thing, do exactly the same at the top as the bottom. Check the cotter pins, check the clevis pins, check to make sure everything's there, nothing's rusted, and check for crevice corrosion.
Yeah, seems okay.
So we inspected the rigging and we found the backstay lower legs get all those broken strands in them, but everything else, upside, up and down, looks great. Looks fine. Old, but there's no evidence of anything that's going to fail. So in that case, we're going to replace the backstay, and I think the whole thing, turnbuckles all the way to the masthead. So the next thing to do is to write this out in the form of an order form. I'm going to send it into Morgan Jones at Sailing Services Miami. She'll send me back a quote, and then I'll add 20% to that and my labor, and then give it to the customer, and he will say, oh, absolutely, that's such a great deal. So this, I just use my phone to do this because that way I can send it directly to Morgan. So backstay, lowers, 2 each. I'm going to wait on the length because I don't know that yet. But this is 5/16 or 8 millimeter. It's the same thing. This is obviously got fraction on the top, millimeter on the bottom. But so the wire is 5/16, and then the pin down here is going to be 1/2 inch. No, it's 5/8. That's 1/2 inch. Oh, that's a little sketchy. All right, so the threads on the turnbuckle are 1/2 inch, but the pin is 5/8, which means there's an imbalance between the pin is stronger than the turnbuckle. The 5/16 wire will go either way. You can get it for a 1/2 inch pin or for 5/8 inch pin because it's slightly stronger than 1/2 inch, but a little weaker than 5/8. But since we have 5/8 pins in the bottom, I'm going to go with the 5/8 inch turnbuckle and a 5/8 inch threads in the turnbuckle, just to keep everything the same size all the way through. So that is going to be a high mod stud 10, 20.
Wait.
So no, first thing first, on the very bottom of this is a turnbuckle left hand eye toggle 20, 20. Turnbuckle left hand eye toggle 20, 30 seconds, 20, 30 seconds, which means it's a 20, 30 seconds pin and a 20, 30 seconds thread. 20, 30 seconds being the same as 5/8. This is a high mod stud, 10, 30 seconds wire, also known as 5/16, and 20, 30 seconds or 5/8 inch pin. So this is the way all of Sailing Services numbers work. The next thing is going to be wire. It's just called WS. I don't know what the S stands for. 10. That's 10, 30 seconds wire. This, I'm building this starting at the bottom. So we start with the new turnbuckle. We go to the stud that's going to take the place of that swage. Then the wire, and at the very top of these two legs, we're going to put in a swage marine eye 1020, right? No, yeah, 1020. So that's the construction. Turnbuckle, stud, wire, swage. Then we got backstay, oops, upper leg, one each. I'm gonna wait on the length for a minute, but this is gonna start out with Schaefer. I think it's a 99-48, but it might be a 48-99 or 84 or something. We'll check that in the catalog in a moment. That's a diamond plate, so that's a delta plate. I'm sorry, the shape of a Greek delta. Then I'm gonna swage both ends of this wire, so it's simply gonna be swage marine eye 12. 30 seconds by 20, 30 seconds. This is 3/8 inch wire, which is slightly smaller than 10 millimeter. WS 12. Swage marine eye 12, 20. That's that construction. It's a delta plate, a swaged eye wire, and another swaged eye. I think. Yeah. And there's probably a fitting at the top that I'm forgetting about. I think I will climb it again and measure that
Fun.
and see what the hell's at the top. The top end, good thing I went up. Usually is a good thing you go back. The top end is is like that. It's a flange. So there's the topping lift, there's the triadic or spring stay, and there's the backstay. Now there's a problem with this backstay, and that is it doesn't toggle. So it allows movement this direction, but it doesn't allow movement that direction. And that can lead to fatigue on the wire. All stays, fore and aft wires, need to be toggled top and bottom because the mast moves enough to cause problems for the wires if they're not toggled. So we're going to take off this link plate construction that doesn't allow toggling and install a double jaw toggle. And it needs to be kind of long. You see how the length between, the distance between this pin and the bottom of the plate is quite a little ways. So we may need to get an extra long double jaw toggle. Oh, that'll work. That's what we're going to put up there. So that's going to go over the plate, and that will allow the stay to move in both directions. That's the toggle. Now we have the full length of the backstay. I'm just going to measure the lower legs, and so I can break that into top and bottom. Yeah. About 17 feet. The overall 47.6, so we'll do 17 feet on the lowers, and then we'll stick with 31 foot on the top, and then do 18 feet on the bottom. That'll do the trick. Backstay lowers 18 feet. Backstay upper leg 31 feet. Now we just need to check and make sure that's the correct Schaefer part number. I think it's ready to go. 34, 48, 12, 20. Oh, we're going to change this their wire is metric, 10 millimeter metric. So we're going to do Swage Marine M1020 WS M10 Swage Marine M1020 DJT20. That's the toggle. Right. Yeah.
So do you have anything else to say to Chloe about rigging inspection?
No, not that one. It pretty much gets it. Yeah, it's just being really careful. Like, trying your best to keep your eyes open. It's tough, you know. Look at every damn thing. There's a piece that doesn't have a bowsprit, but that's the part that I always forget to look at. Not always, but often forget to look at. It's the bobstay. Because they're easy to forget about because you can't fucking see them from the day.
That's true.